Good morning, students. In the last lecture, we have discussed about electric field intensity due to an electric dipole on its axial position. But now we are going to study another topic which is very related with that last topic, that is electric field intensity due to an electric dipole on its axial position. And this one is electric field intensity, electric field intensity due to an electric dipole on its equatorial position. Let me discuss this point. What is equatorial position? First of all, let us consider an electric dipole which is consisting two of the charges minus q and plus q, and there is a mean position that is called O. This can be considered as small l length and this can be considered as small l length. This total distance can be considered as 2l. What is equatorial position? Equatorial position is that position in which that point is being situated equidistant from plus q and minus q charge. From both the charges, one of the point is to be taken which is at same distance. So that point can be taken at this upside, downside, and or we can take it at this upside. Then we can get that particular position of that particular point. So now here from the mean point we are taking that point at a small r distance. Due to plus q charge, electric field is at outward direction. Let this electric field is E1. And due to minus q charge, electric field is always inward or towards that particular charge, that can be taken E2. This point can be taken as P. So what happened to next, that is these both the electric fields are acting at a particular angle, and whenever the angle is being chosen, then electric field is being divided into its component. But before dividing that, we should find out this as hypotenuse of this right angle triangle, and hypotenuse of this right angle triangle, this can be theta and theta, and both the arms would be equal. Let's say this dipole as AB. This particular arm can be represented like under root r square plus l square, and this can be represented like under root r square plus l square. Now just we are dividing E1 and E2 into its component. How will we divide? The horizontal component of E1 would work in this direction, and that would be E1 cos theta, and the vertical component of E1 can be considered as this direction, and it would be E1 sin theta if this angle is theta. What about E2? If this angle is theta, then E2 cos theta, that means horizontal component of E2 would work in this direction, and E2 sin theta would work downward. Let us see in other diagram, if E1 is acting in this direction and with the horizontal it is making theta angle, as these are the corresponding angle. So if this one is theta, then this one would also be theta. So here if this one is theta angle, then this arm can be written like E1 cos theta, and the vertical component of this E1 sin theta would be directing this direction. This can be taken as A of the diagram. Let us talk about E2. E2 is acting downward like this. If we are making a horizontal line, then this angle would also be theta, as they are the alternating angle. So E2, if E2 is acting in this direction, then the horizontal component of E2 would work E2 cos theta, and here E2 sin theta in this direction. This one is the vertical component of E2. This can be considered as diagram B. So what we have considered, I'm just going to write these considerations. These are very important consideration in derivations. So just I'm going to write these all consideration. What we have considered, let us consider an electric dipole which is consisting consisting plus q and minus q charge, let a point P which is situated at small r distance from the mean position of electric dipole and it is equidistant. What is that? Equidistant from plus q and minus q charge. Let E1 be the electric field intensity due to plus q charge acting outward due to plus q charge, and E2 be the electric field intensity due to minus q charge acting what? Acting inward. So E1 is given as, how will you write that E1? E1 can be given as E1 is equal to 1 upon 4 pi epsilon naught q upon, actually the formula is E is equal to 1 upon 4 pi epsilon naught q upon r square. So what would be the r? From this plus q charge, this point is situated at under r square plus l square distance, as this one is making a right angle triangle as POB in triangle what? POB. So here what would be there? Under r square plus l square whole square. This can be considered as question number 1, and E2 may be given as E2 is equal to 1 upon 4 pi epsilon naught q upon what? Under root r square plus l square whole square. From equation 1 and 2, it is clear that E1 is equal to E2. It is clear that E1 is equal to E2. So from diagram or from figure here, E1 sin theta would cancel the effect of E2 sin theta. If E1 and E2 both are equal, then E1 sin theta would cancel the effect of E2 sin theta. What I'm saying? I'm saying E1 sin theta would cancel the effect of E2 sin theta. Thus, net electric field intensity acting at point P is given as, that is E is equal to E1 cos theta plus E2 cos theta, because both are working in the same direction. Because in these diagrams we can see both are working in the same direction, so both will be added and both will be acting on this particular point. So how will you find out these? Let this is as equation number 3. Moving further, let us find out the value of cos theta first. So what is cos theta? As we know that cos theta is written like base upon hypotenuse. So how will you find out that cos theta is equal to what? Base. What is base? Base is in any of the triangle, if you are taking triangle what POA or triangle PBO, whatever you are taking, the base would be small l. What is the base? Base would be small l and hypotenuse will be under root r square plus l square. This can be question number 4. By equation 1, 2, 3 and 4, we get what we are getting here, that E is equal to E1 cos theta plus E2 cos theta. So we are putting the values, that is 1 upon 4 pi epsilon naught q upon under root r square plus l square whole square, and what is the value of cos theta, that is L upon under root r square plus L square. Here also plus 1 upon 4 pi epsilon naught q upon under root r square plus L square whole square, and also the value of cos theta. What is the value of cos theta? L upon under root r square plus L square. As we can see here, both the values are same, so both would be added. 1 upon 4 pi epsilon naught q, and 2 can be written here, r square plus L square whole square, and under root r square plus L square. This can be written like what? P is equal to q dot 2L, as we know that electric dipole moment. So this can be written like this, that is 1 upon 4 pi epsilon naught. This implies that E is equal to 1 upon 4 pi epsilon naught. This one can be P under root r square plus L square. This power 2 and this power 1. So what is the power? Q. And if we want to write it in another order, that we can write 1 upon 4 pi epsilon naught P upon what? R square plus L square power 3 by 2, because under root is taken as power 1 by 2. Here again L is very small quantity. L is very small quantity. Then L square would be more smaller. Then by neglecting L square, we get what we are getting, that is E is equal to 1 upon 4 pi epsilon naught P upon R square power 3 by 2. Here 2 and 2 cancelled out, then E is equal to 1 upon 4 pi epsilon naught P upon R cube. This one is your result. This one is electric field intensity due to an electric dipole on its equitorial position. Remember one thing, in axial position there would be only 2. There is only difference, there would be E is equal to 1 upon 4 pi epsilon 2p upon r cube, but here 2 is not present. So this is only the difference in the result of these two. Thank you.